All right, today we're looking at exponential growth and decay and how to graph exponential growth and decay. So the first thing we're going to do is graph a couple things so we can decide what makes something decay and what makes something growth. So we're going to go into our y equals, and I'm going to erase all those beautiful things that I've already written. And we're going to graph the function 1/2 to the x power. So in parentheses we'll write 1/2. Then we're going to use this little caret button, the up arrow, to make it to the x power. Now, if you were to do anything else with this and you needed to go back down to normal size print, then you would hit the right arrow and that would put you back normal. We don't need that right now. So we'll take a quick look at our graph just to see what we're looking at. So that's the graph we're going for. Notice it gets down here towards the x-axis. What we can't see is that there's like an asymptote there. It gets really, really close to 0, but it never actually touches 0. So we'll see that in our table as we go through. So we're going to look at our table and we're going to graph the things that will fit on our graph. So we're going to start with -3, 8. Then we go -2, 4. -1, 2. Then we have 0, 1. 1, 1/2. Then 0.25, and you'll notice as we go we're getting closer and closer and closer to 0. So if I come all the way out here to 10 just to see what's happening, we're at 9.8 e to the -4. That means it's 0.00098. So we're really, really close to 10, but we never actually touch. So we're going to bring it down, and we're going to bring it over, and I'm just going to run it along this x-axis. So that way we know it keeps going, but it never actually crosses and goes down below. Oops, sorry. So now, when we look at this, this is decay. We're going to graph growth now so that way you can see the difference. If you notice, it's going down. As you read from left to right, like you would a book, it's going down. That would be why we consider it decay. So if we come back here, we're going to graph 2 to the power of x. Same thing, go to our graph. Well, let's look at our graph first. You notice before, as we went left to right, our graph was going down. Here, as we go left to right, our graph is going up. So this would be exponential growth. So let's start by applying some points. Again, notice as we go to the negatives, it's getting really darn close to 0, but never actually touching. So at -2, we have that 0.25, then 0.5, 0, 1. We'll have 1, 2, 2, 4, 3, 8, and then 4 goes up to 16. So again, we get really close to our x-axis without ever actually touching, and then we grow exponentially. Each time you go over 1, it's going to go up more and more and more. It's x growing exponentially. It grows at a really, really fast rate. So here we have decay, here we have growth. If you look at your equations, you're going to know whether or not it's growth or decay. If you look at the difference between 1/2 and 2, 1/2 is less than 1, 2 is greater than 1. That's how you know whether or not something is growth or decay. So it's going to be decay if the base is less than 1, but greater than 0. So it's between 0 and 1. It will be growth if base is greater than 1. Okay, the next thing we're going to do is we're going to look at what happens when we change all the different values, how to move this graph up, down, left, and right. All right, this equation idea should be kind of familiar to you. Here we have our x minus h, here's our a, and here's our k. So we're still dealing with that same type of pattern that we have with all the functions we've done so far. We know normally when it's inside parentheses, here it's going to be up in our exponent, this x minus h. The minus h is going to tell me left and right shifts. So it'll shift left or right. It's always opposite of our intuition. So it's going to go left when we have a positive h value, or when it's x plus something. It'll go right when we have x minus something. Our k value, when it's being added or subtracted out to the right hand side, not in your exponent, just out to the side, that's going to shift it up or down with your intuition. So up if it's positive, down if it's negative. A is your vertical stretch or shrink. Stretch if a is greater than 1. Shrink if a is between 0 and 1. Again, if a is negative, if there's a negative out front, fit it right in here, then this would be reflect x-axis. We're going to talk about what happens when we reflect growth and decay over the x-axis and what that does to being growth or decay. And then the last thing we need to talk about right here is B, your base. This is a new one, so B is our base. It's going to be growth when B is greater than 1, and it's going to be decay when B is between 0 and 1. So let's look at some problems that relate this. So again, up here in my exponent is left, right, opposite. Outside is up, down with your intuition. A is your stretch or shrink. A negative out front will reflect the x-axis. If B is greater than 1, it's growth. If it's between 0 and 1, it's decay. So let's look at a couple examples. First of all, if we have 3 to the x is our function, and we want to compare that to 3 to the x plus 2 minus 4. I can change my base around. All that's going to do, that's just going to determine how fast it grows. We're not going to consider that. That's just the base number. So you don't have to tell me it's a vertical stretch because it's not. That's just the base number. So the 3, the base, has nothing to do with your descriptions of what happens. So here we want to describe the changes, and we also want to state whether it's growth or decay. So from f of x to g of x, we want to describe what changes. So we have this this x plus 2 up here. That's going to shift my graph left 2 units. This minus 4 out here to the right hand side, that'll shift my graph down 4 units. And then we need to state whether it's growth or decay. Because this value of 3 is greater than 1, this would be growth. Next one we want to look at is we have 3 over 2 to the x and negative 3 over 2 to the x plus 3. So when we look at this, I'm going to start with looking at this original function. This original function, yes, it's a fraction, however, it's greater than 1. So we're starting with a growth equation. It's going to, the negative will reflect the x-axis. It does not go left or right at all. The plus 3 out here is going to have it go up 3. What we need to consider when doing growth and decay is that this was a growth equation. However, we then reflect it and shift it up 3. So it did look like this. Our new equation went up 3 units, and then it reflected. So it now looks like this. So it flattens out, but it's going down. If you look at that, that doesn't appear to be exponential growth, because as you read from left to right, it's not growing exponentially. As I go left to right, it's going down, but it's not coming down in the same way in which a decay function goes. Because if you remember our decay function started up and then went down. This is decay, this is growth. This doesn't fit either mold. So we're going to actually say this is neither growth or decay. It's neither one of them. It was a growth function that's been reflected. If you want to state that, that's fine. However, it's no longer exponential growth. There are no applicable situations that would model this. We're going to look at graphs that reflect, but the applications we do, you wouldn't really see this in an application. There's not a life situation I can match that to. Finally, just looking at if we take a function and we move it, so what is the equation of g of x when f of x equals 2 to the x plus 4 minus 3 is shifted 2 units right and 5 units up. So if we look at what we start with our graph has gone left 4, up 3. So I'm going to put f of x right here because that's where f of x is originally. We're going to take it and go 2 right, 5 up. So we'll go right 2. From here, we go right 2, up 5, so 1, 2, 3, 4, 5. Now, g of x is up here at negative 2, 8. So that's what we're going to use in our function. I know you can't see that very well. Let me zoom in for you. Okay, so f of x was at negative 4, 3. We went 2 units right and 5 units up, so now we're at negative 2, 8. So when I write my g of x function, g of x still has a base of 2. But now because it's at negative 2, we're going to say x plus 2. And it's at positive 8, so we'll say plus 8. And that is my new equation.